everybody. Thank you very much for watching this video. I chose to do option 1, which was using AR in the classroom using HP Reveal, which is previously known as Aurasma. I should have been able to create in studio on my computer and share my auroras with you, but I was unable to. I will go over that in my reflection using Screencastify. For now, I am using my camera to record the narration of my mini project. As a middle school math teacher, I would like to use visuals in the classroom to trigger memories, memories of math facts. The terminology is easy to get lost in along with all the rules. Now, I want to use visuals that do not give them the answers, but trigger recall. Almost create that visual literacy, right? Yes, there will be those sheets that contain formulas, but I would like to have a set of colorful posters that support all the facts that keep building for them. I use mathisfun.com to find my images and links for this project. I've used it for tutoring. I had one of my high school students tell me his teacher uses it, and I've used it nonstop since. I used HP Reveal to use AR technology in the classroom environment because the teaching with Aurasma video was inspiring. I would have old smartphones located at the base of each poster so students that do not have a phone can interact with the poster. If phones end up missing, well, then I'll have to check them out to students and remember to collect them at the end of the class. This is more work for the teacher, but worth it. Okay, so I've created a small document representing a poster I would like to have in my classroom. I did pretty much all this myself using images from the mathisfun.com. The black dots under an image means that it is an aurora that you can scan for additional information. I wanted to use images that sparked a memory, but students can scan the image for more information and a link for a lot more information. Now, I'm titling this poster, Keeping Shapes Straight, Plane Geometry. Well, plane, it's play on words too. I like the plane geometry, but basically, this is something to deal with the shapes. It's important to understand your dimensions. There's an image to help support it, So when kids see like meters cubed, hopefully they're thinking volume because they've got a 3-dimensional object. If they see meters squared, they're thinking of area because they've got a 2-dimensional object. If they see just meters, they're dealing with a line, and we love the points. That's something special. But basically, those are your possibilities. And that is a core of all this. But anyways, the main thing is polygons. Polygons are shapes, flat shapes. There's a lot of different things. Now, here on this tablet, I'm going into HP Reveal. This is the just generic. I want to go into my auras. Now, this is what I have. And I did not complete this whole thing because I'll go over it in a Screencastify. There are concerns about this application. It's changing. Some things are stopped being supported until 2020. They're making changes. I just want to see before I invest too much time into this and see where it's going. But anyway, if I go down here to scan images, like let's go to this dimensional thing. Dimensions. Point, line, plane, and solid. A point has no dimensions, only position. A line is 1-dimensional. A plane is 2-dimensional, 2D. A solid is 3-dimensional, 3D. So a plane is 2-dimensional, 2D, and we're in plane geometry. So I'm dealing with flat. Hopefully those connections, oh yeah, that's right, 2D, without spelling it out for them too much. Polygons are like kind of the beginning there. What is a polygon? Well, is it a quadrilateral? No, polygon. Let's see, this image and why that bulletin board seem to have the shapes kind of spaced out. It kind of helps with reading them sometimes. Is it a polygon? Polygons are 2-dimensional shapes, so it pretty much just goes to an image with a definition. Polygon comes from the Greek, poly meaning many, and gon means angle. It gives example of a polygon, not a polygon because that has a curve, and not a polygon because it's open. So it gives example. Oh, that's right, polygons. Okay, they just have to be closed shapes with straight types. Now, there are different types of them. These, again, are to trigger memory. Regular, seeing opposites can sometimes help with memory. Regular versus irregular, concave. And notice the coloring. Polygons are in red, orange. I like the rainbow. It kind of moves it. Quadrilateral, these yellow, green, blue, purple kind of flow, and anything with the border red ties to the polygons. The same for the quadrilateral, and that's kind of hopefully that visual literacy. They can critically think about that and figure that out. But anyway, as far as these, if you do go into this, it gives you more information. So again, regular or irregular. Interesting. I don't know what just happened there. And that is technology. Oops. Let me go back. Done. Scan. And go back into the types. So there's different types, and it gives definitions with examples. Now, I wish when I started this, I forgot to enlarge the images. You'll see that as I got further along, I remembered to enlarge images, so they got a lot bigger. But here in the beginning, and I didn't want to delete them and redo them. This is a learning process. And I'm not sure if this is going to be supported, so I don't know if I'm going to stay with Erasma, or excuse me, HP Reveal, but I'm just saying for now, this is fun to learn for me. Regular types. Notice the key words. And there we go. Regular types. In here, I've got, just to trigger memory, regular types, regular. Oh yeah, regular versus irregular. They have all the same sides and the same interior angles to be regular. Irregular have different. Anyways, that'll help with that. But my regular types, if you go into this, this gives a chart with a name, number of sides, a picture, and the measurement of an interior angle, because all the interior angles are the same. So I wish this was a larger picture, but I would like to create links so that, like with this polygon, not only would you get this basic definition, come on baby, bring it up. There we go. But you could also double click on it to get to a link over here, like polygons. This is where I pulled from. It would link you directly to this site, which goes in, pretty much regurgitates the information I gave you, gives you the chart, but then also gives you some of the naming methods. And what I like is more visual examples along with questions. And you can go more in depth and study more. These were available on many of these, like with the quadrilateral, I would love to add the basic image. So like here, this quadrilateral. Quadrilateral just means 4 sides. A quadrilateral has 4 sides, 2-dimensional flat, closed, joined up, straight lines kind of thing. Well, I would also like to be able to double click on that and get over to a link on Math is Fun, because it has an interactive that you can kind of play. It's really kind of nice. And also it gives more in-depth explanations. And it also allows questions for understanding. So my poster is to support this site kind of, and hopefully just create cues, a cheat sheet for the kids in class without spelling out the answers. So with the quadrilateral, again, right now I could only get the image. I don't know why it's doing that. And when they would double click on it is when they would get the link to the website. And the same goes for properties. You know, that I probably would not have a link to. But I would like to have each one of these. This would take me directly to the main website, a link, and then do the same thing that I did for quadrilateral. Have generic information about it, just kind of a definition. And then where you can go into, again, if we go over here, each one of them will have a link, like kite. Okay, it gets into a lot more information. And trapezoid, all of that. And I'd also like to have little trivia over here, because the square, guess what? It kind of falls under all of these. It respects all these definitions. So square is very important. And if you go into this regular types, these are the connections I'm hoping this will help make. You can't see this very well. But guess what? A 4-sided polygon is called a square. And basically, quadrilaterals are a type of polygon. So hopefully they're seeing all that interconnectedness. But as you can see, the technology, it's a little bit fun. There are some things they're working out, especially with the takeover there. But basically, this is what I want to do, guys. There's going to be more information here, like, do you know what's important about the square, so that they can relate that it qualifies for all these. A square is a rhombus, is a parallelogram, is a rectangle, it falls into all those definitions. But anyways, it's just this flow, and I'm hoping that they'll see connections. And these posters in the classroom, this is more of a completed of what they'll see. Spacious, inspiring, hopefully, and also triggering memory. That's my project, and then I'll go ahead and let you know how much fun I had creating it. Maybe not. Thanks, guys, for watching.